Hi, I'm Gabe Willenberg. I'm starting my third year at OSU studying mechanical engineering, and I've been a member of the mechanical team for 2 years now. Today, I'm going to be showing you a basic overview of what all you can do with Solidworks assemblies. Now, the big difference between parts and assemblies is that parts are an individual model and exist as a single body, whereas an assembly is a collection of parts with additional relations called mates, joining and constraining these parts. Assemblies are great for your larger overall designs, as they give you the ability to combine multiple parts into a singular file, and allow you to visualize how different parts of a design will interact with each other. So the first step after creating your new assembly is to begin importing your parts. To do that, first you're going to go up here to this bar below your toolbar and make sure you're on the Assemblies tab. Once you've done that, you can go ahead and click the Insert Components button second from the left. Now, once you do that, you should see a file explorer kind of like this pop up on your screen, and you can use that to navigate to the location of the parts you want to add in. Once you've got your part selected, you should see it attached to your mouse, and all you need to do is click somewhere, and it should place the part. Now, this first part you add is going to be fixed, meaning that it can't be moved once it's placed, and that is denoted by this little F here by the name. Generally, you're going to want to make sure the first part you place is your base, so you don't need to worry about undoing that fix every time you start a new assembly. Now that you've got your first part placed, you can go ahead and repeat that process as many times as necessary to get in all of your components. As a side note, if you need to insert multiple components or insert multiple of the same component, you can click this little push pin up here on the top of the import menu, and it'll stay open after adding a part rather than closing every time, kind of like this. So yeah, stays open here and it adds the part to this little open documents menu, and you can have as many things in there as you need to. Now that you've got some parts in your assembly, let's talk about how you can move them. When it comes to moving parts around an assembly, there are a couple ways you can do it. Easiest way to move them around, though, is to click and hold on your part, and then you should be able to drag the parts around as necessary. This isn't a particularly accurate way of placing parts, but if you just need something out of your way or in a general area, it works great. If you need a more precise placement of your part, your best bet is going to be to use the Move with Triad command. To do this, simply right-click on any part that's not fixed and select the Move with Triad option from this menu with the little 3-axis symbol next to it. Once you select this, you should see 3 arrows corresponding with the 3 axes, as well as arcs on the YZ and XZ plane, and a circle on the XY plane. Now that you've got all that up, you can use the arrows to move your part with a good degree of precision along those 3 axes, and you can use those arcs and the circle to get rotational motion corresponding to the plane to a good degree of precision as well. Now that you've got some parts in your assembly and you know how to move them around, you need to learn how to add constraints, which are important for making sure that your assembly is fully defined, or at least as close to fully defined as possible with the design. Having a fully defined assembly basically means that the exact location and position of every component within your assembly is known. For most of your parts, this will be done by locking them in place in relation to other defined parts. This is done using the Mate tool, found up on the toolbar next to the Insert Components button. Once you click on it, you should see a menu that looks like this pop up on the left side of your screen. You've got a lot of different mating options, but the ones we're going to talk about in this video are going to be Coincident, Concentric, and Distance, since these are the ones you're likely going to be using the most. We're going to start off with coincident mates. This mate is mainly used to join 2 flat faces to each other, like so. Now, sometimes you end up with a problem kind of like I have here, where the planes are aligned, but the object is facing the wrong direction. Usually, it's an easy fix. What you're going to want to do is come down here, above the Advanced Mates tab, and you're going to change your mate alignment. So, it's not rotated the correct direction, but the planes are lined up properly and the object is on the right side of those planes, so this is going to work for me. Now, you can see, now that I have the object mated, I can move it around, but it's actually not moving off of that plane. This is easier to see from a top-down perspective. If we come up here, you can see that I can slide it left and right on that plane, but I can't actually pull it off. Now, I'm going to go ahead and add a couple more coincident mates here. We go one on that plane. We can do one on the top. And you can see I am actually no longer able to move that triangle. Now, in general, this mate is great for parts with flat faces that don't need to be able to move relative to other nearby parts, like if you're attaching something to an internal frame. Okay, next, let's go over concentric mates. These are going to be what you use if you have a part that's round. The concentric mate allows you to perfectly align the center lines of two circular features like so. Just like with a coincident mate, you can reverse the mate alignment, though in the case of a part like this that's symmetrical, that doesn't really matter. Now, after I apply that mate, you can see I can still move it up and down along the center line of those two circular features, and while it's a bit hard to see, it is actually still able to rotate about that line. What it can't do is move off of that line in any direction. Now, this mate is mostly going to be used with screws or pins or sometimes axles, and in the case of screws, you're probably going to be using it with a coincident mate, kind of like this, to ensure that your alignment is correct. So the last mate I'm going to discuss in this video is going to be the distance mate. This mate works similarly to the coincident mate I discussed first, but with the added benefit of being able to set the exact distance between the two faces selected, rather than just having them joined. The distance mate is down here on the left, right below the lock mate, and to use it, you're going to want to click that little box and then set the exact distance you want between your faces. In this case, I know we need 3 inches from the bottom of our square-shaped hole to the base of our square-shaped block. So go ahead and set 3 there. And then what you're going to want to do is select your two faces just like you would a coincident mate, and you can see it locks them here at that height. Now if we jump on over to a side view here, you can see I'm still able to move this block up and down, but I can no longer move it out of that exact height. And oftentimes this will also be used in correspondence with coincident mates to lock an object in an exact space. So as you can see here, adding a couple of those to the sides, I will no longer be able to move my blue square. Now, you're mainly going to be using your distance mates if you have a part that needs to be in location relative to a specific feature, but you don't have another feature to join it to. Say you have a pin that needs to stick out exactly 1 inch so you can mount another part onto it. I'm going to take this last part of the video to talk to you about some good organizational practices when it comes to assemblies. First off, you're going to want to make sure that your assembly and all of your parts are in a folder specifically for that project. Keeping everything in one folder helps prevent pathing errors, and making sure it's a folder just for that project keeps things from getting cluttered, especially since your larger assemblies can have dozens or even hundreds of parts. Another good organizational tool is to make sure you give your parts good descriptive names, since it's generally easier to import your parts based on their name, rather than trying to look through all the preview images. It's way easier to find what you're looking for if the file is named number 8 screw 1.5 inches long, as opposed to screw_3. Another big organizational tool for those really big assemblies is going to be using something called a subassembly. Just like you can with a part, you can import an assembly into an assembly, which can be a big help on your really large projects with multiple complicated subcomponents. Finally, I want to take a second to talk about the best tool for sharing and transferring assemblies, Pack and Go. Pack and Go is found under the File tab up here at the top of the screen. And what it does is it takes all your components and subassemblies in your assembly and compresses them into a single folder or zip file. On the team, you're mainly going to want to export as a zip file just so it's easier to upload, but both can be super useful. Pack and Go is especially useful if not all of your parts ended up in one folder for some reason, because it will repath everything so that there aren't any issues when the zip file is extracted and everything is now contained in a singular folder.